I'm Stephen Foskett, the organizer of Tech Field Day, and the video you're about to watch is a Tech Field Day presentation from November of 2016. We have invited a panel of independent writers and speakers from across the internet and around the world to join us here in Silicon Valley to meet with various companies, discuss their products, and learn about their technologies. Right now, you're going to learn about Igneous systems. You can find out more about them. You can find them on Twitter, Igneous.io. You can go to igneous.io. And if you'd like to learn more about this event, just go to techfieldday.com or view more videos like this at youtube.com/techfieldday.
Hi, my name is Jeff Hughes. I'm the CTO and co-founder of Igneous. And I want to tell you a little bit about this cloud-managed aspect. And it's good to highlight this a little bit because a lot of what we did was take basically the strategies that we saw in the hyperscale data centers and said, how can we bring some of those same strategies back to the enterprise data center where this data is not able to make it out of certain workflows and whatnot. So when I think of hyperscale, I think of something like this, evaporative cooling and beautiful data centers that are built from ground up, very much not like the enterprise data center. Or how about physical containers where I can get compute on demand maybe? No, that's probably not it. Lights out data centers. Really, it's about the software. And there was a whole new class of software and automation that came about in the hyperscale data centers that we saw as pretty different than how enterprise data centers were being ran. And that really came down to that public cloud experience that Karan talked about, which is really everything is as a service. There was a question about SLAs and how do we offer that. We think of ourselves as a service provider and how do we go do that? And that was key in changing the experience from the end user as well. But it's also about the hyperscale efficiency. How do you go use machines to manage a whole class of issues that existed in the world that you don't have to manage at the hyperscale level because software's doing that now for you? So how do we bring some of those same strategies back? I always like to start with where we saw it begin, which is, you've got the hero IT administrator in the center of putting together kind of a multi-vendor strategy of how do I build out my data center, and I'm supporting some applications that run within that. And there was a lot of work to go do in that picture, and yet you really wanted to focus on supporting your applications, being more of a business analyst in this front. Instead, you were doing things like scaling and provisioning infrastructure. When issues come up, you're on the line to go put together a plan of, I need to talk to this vendor and get them on the call and spending a lot of time on, choose your favorite WebEx or whatnot. Then you're also on the train of, hey, I've got to go refresh my hardware now because it's been 3, 4, 5 years, and now you just keep going through this cycle and over again. And it's this train. In fact, we get a lot of times talking to friends of ours who are just totally frustrated with this. And so we said, how do we go about this? And it really came back to, again, looking at how do we go automate more of that activity so that as the infrastructure scales, that problem doesn't become completely untenable. It's not a matter of eliminating people out of the equation. It's how do we go manage more infrastructure with what's not a growing workforce today in some ways. So what we see is applying the same strategies that happened at Amazon and Google and Facebook and Microsoft, which is first start and observe everything that's going on in that data center and understanding what's actually going on the ground. 2, taking the insights in front of that, building massive automation to go get in front of issues as opposed to just automating the things I do every day. And then 3, integrating those learnings back into automatically applying updates across the whole system. We saw doing those same strategies, but instead of having it managed in a few regional locations, why don't we do that across the internet for individual installations across many customers? Is that we can go run the same sort of fleet management techniques, if you will, but within individual installations out there throughout the world. Is this making sense? Mm-hmm. Okay.
It's the end of our day. Bear with us.
That's sink in slowly. We'll be there.
Okay. So we've got the center of this, if you just zoom in a little bit on that picture, is that we have a cloud management platform, which is our own kind of software that is out there. And think of it as kind of like either a knock in the sky that's receiving telemetry and also able to do some various operational things with individual instances out there in the world physically somewhere. Now we can go apply those fleet management techniques across a broad array of installations across the world and treat it as one fleet, while still all the data stays local within each individual site. There's complete no visibility into that. It's just a control plane that exists across the cloud, and the data plane still lives in individual customer sites. So that allows us to do things that are very similar to the public cloud. We've got things like auto provisioning. Now you're no longer configuring to add something. You just plug it in and the software takes care of the rest. We're able to monitor everything so that when something goes wrong, our goal is that we obviously see that way before you would see your applications have issues, and we would proactively manage that situation. Upgrades are 100% automated. This is a service. You don't have to worry about what software is behind it. We offer an SLA, and we hold to that SLA, and we move the software forward ourselves. And then we have service-oriented teams. So the folks who build the software are also managing what's going on out there and making sure that it's operating well. And so we get a lot more insight into our development process that you wouldn't normally get when shipping a product like I've done in the past and just throwing it over the wall and seeing what happens. All right, so I could kind of belabor what the individual things here are, but it's Tech Field Day, so I want to dive into a little bit of examples of what does this actually look like. And I'll start off with the installation process. As opposed to the traditional installation process where you put some gear in place, you plug in serial console, you start typing up some stuff on the command line, we went very much more the consumer route. Think of this as like the Kindle experience. Hey, you buy the Kindle, it shows up, already know who you are, all your books are going to load automatically over the internet. It's the same thing here. First step, set up the network. It's just basic IP information, DNS, gateway, etc. And once it connects up, it automatically talks to our cloud, downloads the latest software, and then pulls down all the appropriate settings. And within 10 minutes, you've now got a fully provisioned system that there was really only one human action, which was connecting the first device up to the network. And then everything else follows in behind that. So it really can be a different automated process than what's out there today when we have this kind of global intelligence out there. The other aspect is really that fleet level aspect. So very similar to many systems, we're going to health check individual services both across every layer within our infrastructure, both from a hardware, software, everything. And then we're able to get that telemetry back up to our central cloud environment. And then what really becomes interesting at that point is that we get a global view of what's going on in the fleet at that point. So we can do things like, hey, is there a local issue going on here, or is there something more systemic? Maybe a certain batch of drives had some issue, and we can start to observe those things as they're happening, or even before there's end results of, hey, I'm now in a serious, data integrity issue. We can proactively start making decisions about those things just because we have a global view much earlier in the process of how those things start to come about. And so this one's huge, is that we get a lot of value of being able to kind of see emergent behavior before it actually becomes end user impacting and go correct it before it does. So when those things do happen, there's always the question of, okay, what sort of actions can you guys go do? Well, we have many of the standard things of, hey, obviously we're going to have sorts of inline error handling in the cases we think about. There's watchdogs of various varieties out there. But the thing that can be very interesting when you start bubbling up to the remote control level or the cloud level is that we've also implemented kind of a belts and suspenders approach. Just like in a cloud data center, you have various control planes of how do I go not have a human go reboot something, but some machine says, oh, that thing's acting weird. Let me just go reboot it and see if that fixes the problem. We've implemented a very similar approach of we have the ability to go implement some of those things automatically with appropriate controls in place from a security aspect and whatnot, but having that other lane of control so that humans are not the next default. As soon as something goes wrong with a product, a lot of times people get involved and have to go do those things. I know that I've had to ask customers, oh, can you go do this for me? And we wanted to take that equation completely out of it. So our goal is really to get down to humans only need to get involved, and they still do at various failure scenarios, but at the very lowest percentage of cases. And then last but not least of examples here is really about software management. And for this, we think of this as a fleet problem. in the sense that, look, software is something that is just always evolving. I've heard the great saying of like software is best delivered as a service because it's always changing. And the challenge with a lot of infrastructure these days is that there's always this gap around, oh, I've got new software install, and to get the new things I want, I need to install the software. And Asif will go a little bit more of how we develop that. But I want to take the fleet approach, which is really the difference between updating software across a service and that of individual systems is about risk mitigation, is that we're able to get much faster sort of iteration on understanding what's going on with a piece of software and fix issues before they become really big. So first of all, we can do granular level updates. We can update just one service at a time within the infrastructure and understand what's going on there. But if something does go wrong, we ensure that everything is reversible, that we need to maintain SLAs, which means the first reaction, if we ever see, hey, we install a new piece of software and something goes red or yellow, we immediately can roll it back. But if it does go well, we can progressively roll that out. So very similarly, we can now get software changes out into our customer base within hours at this point in time, with still minimizing that risk. So let me just walk through an example of what I mean by that. A common way of thinking of this is you start with a small percentage of the fleet. Maybe in this scenario, we start with just 4 sort of services or 4 individual systems across a big installation. We can now progressively ramp up the amount of things that we can currently install across the fleet until we can start getting really good confidence of what's going on here. And this is all automation driven from our cloud, but we can do it even on an individual customer level to minimize risk in each site. Okay.
Processing that. So like is wave 1 in your lab?
So there's 2.
At some point you tested it, okay, it was okay here, we'll test it with a couple friendlies, okay, it was okay there, we'll roll it out a little wider.
We certainly do things within our own lab of rolling that out, but you can think of this even within a single system. So I'll talk a little bit later, but we have a whole, in a basic installation, minimum installation, we have 62 devices to install across. So we can install that across just a couple of those devices. And since everything interoperates, we think of it as a service that's always working together. We don't have, flash forward to the new software. We upgrade just 2 of those 60, see if everything's good, maybe roll a couple more, and then just keep ramping up the speed while maintaining that everything's online and available. But we can do that within even a single site. So even the risk at a single customer is minimized at that point in time. Does that make sense?
Yeah, that makes sense.
So do you have to worry about dependencies in that case if you have 62 components? I assume there's some sort of defined order that you would set them up in?
There's a little bit of order, but in most ways we look to support both. Since we have to have everything reversible, you have to support kind of forward and backwards on everything. So yeah, we have to roll through it kind of a certain direction, but we have operability between versions, plus and minus quite a bit.
Okay.
And if you have to roll back, is that disruptive?
No.
Or are all upgrades non-disruptive?
All upgrades are non-disruptive, yes. So that's all around how we split out the services and how we roll forward there. And we'll have more on that later of kind of what that looks like. But yeah, a key aspect of this is that we have a lot of granularity of what we can update. And that's pretty big of how we can be very non-disruptive.
Are you running microservices under some of this stuff?
We are, yeah. Yeah, we run an extensive set of microservices, and Asif will go more into like how we built this. But yeah, both at a system level and within a single system, we can upgrade individual services within it. So we have a very decomposed architecture from that perspective. So that was really the one aspect here that I want to throw in there is that also when you think about fleet management is that we think of moving the whole fleet forward, which means if you have a different piece of software for one system versus another, we actually view that as a risk at that point in time because we like to observe things as one whole fleet, which is very similar if you ask how this works at kind of the hyperscale level, is that they only have one version out in the field. That's what's running right now. And that vastly reduces risk across what that whole fleet operates as.
Is there a term for when you have to, how long you'll keep the appliance? Anything like that? Can you cancel at any time?
Right now we do year increment contracts, but that's something that we've also explored other options of as well. So.
Okay. On your website, it says that it's pay as you go, but earlier we heard that it's more like it's 200 terabyte chunks at a time. And one of
Do you want to offer this one up?
Yeah, I
Ron?
will have the.
Oh, here you go.
Yes. It is pay as you go in the sense that we don't have the same level of granularity that exists in the public cloud today, but it's a lot more granular than what exists in the traditional on-premise world. So it is a 212 terabyte increment. Customers sign up for that on an annual subscription basis. So from a customer point of view, what they're out of pocket for is substantively less than with typical infrastructure. Furthermore, given the customer use cases and workflows we are after, the data sets are large and growing enough that 212 is a minimal amount from their perspective. What they sign up for is as little as 1 year prepaid subscription. We do offer multi-year subscription as well as discounts, volume discounts, as the capacity that they have deployed and used sort of grows. Very, very similar to the Amazon and Google models, if you will.
So do you see your customers seeing this as a CapEx expense or an OpEx expense like cloud?
Customers today are seeing it as an OpEx. Again, very flexible with regards to how we work with them. But the differentiation is we offer it as essentially an OpEx service. Should they be interested in taking that up? And everyone has taken us up on that so far.
To what extent can you multi-tenant this? So either across different customers or lines of business or similar?
So as Jeff pointed out, the product has been sort of architected ground up to be highly decomposed and highly separable. So multiple workflows, multiple use cases is something that we have thought about from day zero. In fact, in Asif's presentation, you will see a quick hint of what we think of as QoS for the data layer as being implemented and incorporated very early on. And that is primarily to address things like noisy neighbors and so on and so forth.
And then in terms of authentication?
Today we support essentially an S3-like authentication, so it's a bucket key model.
Right, okay.
That's kind of where we lived in.